The plan is to, I'll give a brief introduction. Welcome, everybody. Then we're going to have a keynote speech from Andrew Bradley, Chair of the Aerospace Division. I'll let Andrew introduce himself more fully when we get to that. Then you can see we'll then have the panel discussion. I'll introduce the panel members, and again, they'll give a short introduction to who they are and their background. And then I'll go through a number of questions that we can ask as we go through. Again, we've got minutes or 40, 50 minutes, so not a lot of time. I've got a number of questions, so thank you all for those questions, which we'll pick up. If you've got any comment, you'll note that you are muted, and please, if you're not, please can make sure you're muted because the background noise can be overwhelming. Certainly, you've got any questions or comments as we're going through the questions itself, or again, any comments that are going on, please can you put them in the Q&A panel at the side, the chat box at the side, please. I'll do my best to pick them up as we go through. Certainly, any supplementary questions you have as we go through, I'll do my best to pick them. This has all been recorded. Any comments you have, I'll usually use those, and I'll explain a little bit more about that as we go on. I think without further ado, I think we'll probably move to our keynote speech from Andrew, who's the Chair of the Aerospace Division, and I'll let Andrew introduce himself and give us our keynote speech. So, come Andrew, carry on.
Thank you, Paul. I'm Andrew Bradley, Chair of the Aerospace Division of the Institute of Mechanical Engineers, and recently retired from Rolls-Royce as a Chief Design Engineer. I welcome this opportunity to talk about trends and developments in the aerospace industry. We hear how the travel industry, in particular flying, has been hit hard by COVID-19, as this competition itself has been. But at least we are starting to see a return, albeit very small, return of flight schedules. However, the industry expects revenue passenger kilometres, that's how we measure the demand for flying, to be 50% of 2019 levels in this year, and not get back to 2019 levels until 2023, by when the industry would have been expecting a growth of 20%, and they were planning on that. In the face of this, you'll have heard how many of the big aerospace companies are cutting back on staff levels to keep their companies financially viable in the short term. However, I and most others in the industry expect that there will be a return to strong growth in the sector, particularly driven by demand in India, China, and some other countries, as their financial growth, GDP per capita, enables many more people to fly, to visit friends, relatives, and go on holidays, as well as increased economic activity. Many governments around the world are seeing this as an opportunity to help the industry on its journey towards net zero environmental targets for 2050 through targeted research and technology investment. The UK government has announced Jet Zero Council, tasked with making net zero emissions possible for future flights. It's a goal that within a generation, flight across the Atlantic without harming the environment is demonstrated. This could be via a fuel that is renewably created on the ground, such as hydrogen or other synthetic hydrocarbons, or a novel means of energy storage on the aircraft themselves, such as advanced batteries with much higher energy storage per kilogram compared to today's capability. Separately, we see that there's a pent-up demand for flying taxis that can transport people from airports to city destinations, avoiding congestion that is steadily getting worse. In the past, this has been the preserve of the very rich using helicopters, but using electric flight for the environment and simple and reliable control, together with autonomy so that there is more passenger capacity and that there are no highly skilled personnel required to be on standby waiting for you or travelling with you. This has the potential to have much greater affordability. The trade between payload and range will particularly have been appreciated by the designers for this UAS challenge, with all of their tasks that they've been trying to deliver. The renaissance of supersonic air travel was slowing down even before COVID-19 hit, delayed by a combination of technical, financial, and other factors. Some business jet flights have been pushed back in time, as in the Boom supersonic aircraft, which was an airliner, has been pushed back to the end of the decade. But these delays, announced before the crisis hit and unrelated to the pandemic, mean that new supersonic aircraft should be coming onto the market after aviation has recovered. The market rationale for these aircraft should be unchanged, and in fact, many of the rich people will choose to use business travel to business jets to avoid having to mix with many people and risk themselves against these pandemics. Though that may be a more convincing argument for the business jet than the supersonic airliner. Within military fields, there is a growing interest in hypersonic weapons. Hypersonic weapons provide advantages for time-critical targets, mobile or relocatable targets, or in the face of missile defense capabilities. There are great challenges inherent in developing hypersonic weapons, particularly in areas such as propulsion, airframe design, guidance, and thermal management. Also of great interest is and greater complexity and autonomy as the move towards unmanned combat vehicles create the requirement to track and acquire targets and respond to aggressive threats, as well as interact with other friendly vehicles. I've just touched on a few of the potentially exciting developments over the next decade. Whilst the immediate future looks grim as the world recovers from COVID-19, I expect a resurgence in the field of engineering to provide great innovation in aerospace engineering, away from a fairly fixed format that we've had over the last few decades, typified by civil aircraft with a tube, low wings and engines slung underneath. For this, we will move into a period requiring more, not less innovation, requiring more innovative engineers. We see that the key learning experiences from the UAS challenge of economical flight and autonomy will form the bedrock of that innovation. And it's been great pleasure to see all the exciting, innovative ideas that have been coming through this challenge, and being able to see what the sort of engineers we're going to be faced with in the future, and look forward to your contributions. So with that, thank you for your attention, and I'll hand now back to Paul and the panel.
Thank you very much, Andrew. Really interesting. Thank you for insights there. And there are a number of topics I think that you've raised that up in the questions. Certainly around flying taxis or helicopter UAVs. There's certainly a question there that I know we'll wish to get into. And again, as I keep saying, if anybody out there has got any thoughts or comments on anything that Andrew said, please pop it in the Q&A at the side. We can then pick that up and again either raise it during it and go back to Andrew on anything we've raised, or certainly through the division. Again, we're Aerospace division behind the key. We're always interested in the areas to look at. So now we'll move on to the actual panel discussion itself. And I'll briefly introduce the panel themselves. Well, we'll just do their names and let them a short introduction to who they are, and then we'll move through the questions. I guess before we start, I should probably say who I am. So I'm Paul Lloyd. I'm the chair of the UAS Challenge. I used to be, previous to Andrew, the chair of the Aerospace division. So again, heavily involved in that side of the business. So I've given honour now to the panelists. First up, we've got Malcolm Foster from GKN. So Malcolm, maybe a short introduction to who you are.
Yeah, my name is Malcolm Foster with GKN Aerospace. I'm the Director of Special Projects. Projects is essentially anything that's not part of our existing core business, emerging markets. So at this point, I'm extremely busy. There's a lot of new stuff going on out there. My background is largely in helicopters, working for Augusta-Westland, which is now Leondardo. And then before that, for 20 years, where I was the head of the preliminary design department.
Thank you, Malcolm. So Steve has joined us from Meggitt. Steve, are you able to give us a short introduction to who you are? We appear to be having a problem with Steve's audio there. I'll come back. I think the same problem. Andy Merrick has struggled to join us as well. So I'll come back to Steve and Andy in a moment. Hopefully we can get your microphones working. So I'll move on to Stephen Phillips. So Stephen, who's the Vice Chair of the Aerospace Division. Stephen, a quick introduction to your background.
Hi, yeah, so I'm a staff stress engineer, and I've been working in aerospace for the last 15 years, and I've been able to cover quite a bit structurally. I've been involved in the design and development, testing and certification for pretty much the majority of aircraft structures from nose to tail. So I've a kind of wide experience on the structure side of it, and my specialty in my day job is fatigue and damage tolerance. And also, as Paul mentioned there, I've been involved with the institution for probably about 8 years now, from coming in as a young member and helping with the Aerospace Division Board and the UAS Challenge.
Thank you, Stephen. Good. Hopefully, Steve Parker, hopefully your microphone working. So, Steve, you're able to give us an introduction?
Yes, apologies for that. That was finger trouble on my part. So, good afternoon, good morning. I'm Steve Parker from Meggitt, Assistant Chief Technology Officer. As some of you may know, Meggitt is one of those companies that kind of flies below the radar to an extent. It's largely Tier 2 and Tier 3 equipment supplier to aerospace, both civil and military. Occasionally a Tier 1 as well. So we supply equipment and systems, which is very, very wide, ranging from sensors through wheels and brakes, through composites, polymers, heat exchange systems, thermal management, flow control. The list goes on and on. As Assistant Chief Technology Officer at Meggitt, I'm engaged day to day in Meggitt's global research activities. So I have an overview, I take a view of all of the research activities going on across the business. So I spend a lot of time looking at new technologies and new things that are going on in the world of aerospace. My background, I've been in the industry for a long time, since 1979. Initially at BAE Systems in Rochester in Kent in the UK, working on underwater weapons at that point. And then moved to join Meggitt in 1993 to work on cockpit avionics, and I've been at Meggitt ever since, serving a period as engineering director at Meggitt Avionics in the UK, and then moving to the group role in around 2011. Thanks very much.
Steve, unfortunately, Andy Merrick, struggling to get Andy Merrick, so I'll move off Andy. So, Andrew, obviously, you've introduced yourself. Martin Soltau from Frazer-Nash. So, hello, Martin.
Hello, Martin Soltau. I've got a background in the aerospace industry all my life. I initially started out systems engineering and then program management, leading programs to put tactical reconnaissance onto fast jets all around the world. Been working for Smiths Aerospace, now in GE, developing avionics for both civil and military aircraft, particularly into Boeing and Lockheed. A spell in the States on guided weapons with Lockheed Martin. And I've been leading the aerospace business for Frazer-Nash Consultancy for the last nearly 20 years. And I'm one of the committee members for the UAS Challenge, and I'm afraid the person responsible for setting the evil rules that everyone has done a fantastic job in meeting.
Thank you, Martin. So I expect there'll be a flurry of comments about your rules in the panel any second now. So we'll do that. So welcome everybody to the panel discussion. So I think we'll get on with the questions. So I guess before we dive into the first question, I was going to ask you, I was going to say that I hope you'll see now, and just to prove that we can count. So that's question 7. So I just thought what to do is just to bring that up as one of the later questions we're going to come to. And whilst our first question is on a similar theme, you'll see, and I just thought this is quite an interesting discussion. So as you see here, the question: the shortage of engineers to meet the growing demand in the aerospace sector, and on a particularly acute in the lack of women seeking careers in engineering. And again, what we do to attract more people to engineering, not by the government, but also schools versus. And whilst I'll clearly move that to the panel in a moment, I'm very conscious that I'm probably predominantly talking to of engineers out there. So clearly you have all made the choice, some of us a long time ago, to move into aerospace engineering or engineering. And I think what I'd really appreciate is as we go through this, please, if you've got any thoughts or comments on what attracted you to engineering, or certainly looking forward to what you think we should be doing to attract more people into engineering, then put your comments please in there. Just a statement is great. As I said, this is being picked up. We're going to, as part of the aerospace division, wider than just the UAS channel, obviously we're part of the division. We'll pick those points up later, and they're always useful for reflection on how the institution and the wider government, etc., can do to help promote engineering. So I just thought I'd put that up there, and please, as we go through this, pick up any questions. I'd already seen we started with John, your question is useful. Again, we'll come back to that. I think we'll come back to a later conversation anyway. So if we move to the first question. So again, a similar aspect, I think a little bit further down in terms of those people who move into engineering. So again, the question is, if you're graduating this year, what advice would you give to prepare for you for a career in the aerospace industry? And I think I'll turn to Malcolm first for your thoughts, Malcolm, on that question.
Thank you, Paul. This is kind of a difficult question for me to answer because I don't know that I've ever made any specific decisions about my career direction throughout my career. It's just kind of happened, and I generally have just chosen to do what sounded like fun at the time, and to be honest, that's kind of worked out for me. And I've pretty much always enjoyed my career. I've always found it to be extremely challenging, but very interesting. So primarily, I think my advice would be just find something that sounds like it would be a lot of fun to do and just follow that up. The other thing perhaps that I think people need to bear in mind is read the press, keep up to speed. I know that the next 10 years, things can be changing really, really quickly. So I would advise everybody to make sure that they do everything they can to keep themselves aware of future trends and what's happening.
Thank you, Malcolm. And I think a lot of people would recognise in terms of certainly starting your career off with an idea and then yes, come and see what you're interested in. That's really important. So thank you for that. Steve, again, just interested in your thoughts on that particular question.
Sure, yeah. In many senses, I agree entirely with what Malcolm has just said, partly because, like Malcolm, I've never really had a planned career trajectory. I kind of fell into. Well, my plan was to be an engineer, and then everything since I became an engineer has been an accident of chance. If I were giving advice to someone looking to get into the industry now, I think there's a couple of things I would say. Mainly, it's about making sure you're prepared for the industry. So by that I mean that when new graduates come out of university, oftentimes there's quite a variability in how useful, as it were, to industry those graduates are when they come out of university. So I would strongly advocate trying to get experience in industry during your degree course. So whether that's through internships, Meggitt employs a lot of interns for typically 12 months as one of their years of their degree, but if it's only during the summer, get into industry and get some experience under your belt and try and find out how industry ticks, because it's not the same as academia. And then once you're graduated, I'd strongly advocate trying to find a business which provides a well-structured graduate development program. And a number of businesses do all over the world, and actually it tremendously advances your career. If you can get onto a good graduate development program, it will advance you in your career beyond anything that you can do just through going in as a graduate and working as a graduate engineer in the company. A well-designed development program adds a huge amount of value to you as a person and you as an engineer. I think that would be my main piece of advice. As I said, I'd agree with Malcolm. Do what looks like fun, because you're going to be in this industry for a long time, so you want to enjoy what you're doing. There's another piece of advice that I was given by one of my colleagues fairly recently. Actually, it's too late for me. one of the things that he said was actually follow the money. So the most active parts of engineering tend to be where there's an active and growing marketplace. So if you can identify those areas, I think there's some discussions earlier on about where those areas might be in the current environment, with electrification, with the environmental challenges and so on. Find those areas where there's lots of activity going on, and you'll find lots of opportunity.
Thanks, Steve. Really good advice. I absolutely agree with you. Again, to see where things are going, and again, I think getting experience, I'd absolutely recognise that. And I was lucky in my school, so university holidays, able to go try out a few jobs, and I should say some areas that proved me I didn't want to go to, rather than wanted to go to, and sometimes that could be as useful. So yeah, but absolutely, I think it's a really sound advice. Stephen, what's your views on the question?
So yeah, I'd echo the guy's view there, as following what you say you think is fun or what you think is interesting to do as kind of a key priority. But also I'd like to say as well that I didn't do an aerospace degree. I just did a mechanical engineering degree, and after graduating, stuck my hand in it to try and apply for quite a few different roles within engineering. And one opportunity came up to join the aerospace industry. And as Malcolm said, before I went to that interview, I didn't really have an awful lot of experience or a view in aerospace, but I went online and read absolutely everything about what planes do, what the company was making and how they were making it, and being informed of what's going on, the trends and latest technology in that industry was definitely a benefit. And I think that's what helped me land my role within the company I work for now. I'd also kind of say as well that don't be afraid to go for different tiers of companies. A lot of people try and aim for the top tier companies like Airbus and Boeing, but throughout every level, there's interesting jobs available to go through. And while some of the top the manufacturers might have really structured graduate programs, which are very good and give you lots of experience, you'll find some of the smaller SMEs have less rigid graduate role, and you can gain a lot more different experience in that kind of role, and maybe get more responsibility quicker than you would for a more kind of a prominent company. And then the other thing as well is go and join the IMechE and do challenges like this and get involved in lectures and webinars and networking and meeting experienced engineers. One of the things that I've learned through my career is if I don't know something or don't understand something, I find who's the experienced person that knows that and go and talk to them and find out about it. And that's the way you build up your knowledge and get yourself to be a better engineer within the industry.
Thank you, Stephen. Yeah, I mean, and I absolutely agree. I think interesting point you raised there about the size of the company, and you're right. I think Steve's point around a good structured graduate program can help. I'm in the Air Force, I should say, so I joined the Air Force. We had a very structured program, very useful for helping me. I think, and the kind of person I was, I probably needed that. But you're right, probably get made responsibility a little bit earlier in some of the smaller companies around. So I guess you need to balance that and what type of person you are. And again, I think that's important to know yourself, isn't it? What kind of person are you? What sort of thing are you more entrepreneurial? So therefore, do you want maybe a smaller company? Or do you maybe a more structured rigid one? You can find a role in that bigger company. I think that's a really interesting idea. But again, you know yourself first, or at least think you know yourself. Have a go at what it is. That's really useful. Thank you. So I think again, Andrew, from your perspective.
Yeah, and there's a few points that I'd like to, first of all, like going on Steve's, is that a lot of engineering is about working together. And in order to work together, you're going to need to share ideas with people, share where you don't know, not just things that you do know. And by sharing that knowledge, you're learning and you'll gradually develop better products, and you'll get more enjoyment out of it, and they will get more enjoyment out of it from sharing those sort of ideas. And a key element of it is that you'll never stop learning throughout your career. and that includes the greybeards that you may see around you. They won't know everything, and they will enjoy working with you to find out new things for them as much. So don't stop learning. That's what I'd like to say. Okay.
I don't think you ever do you? I don't think we ever stop learning, do we, Andrew? As I said, I've been in the Air Force 29 years now, and my joke is every day is a school day. I learn something new every day. So you really do never stop learning in this industry. There's always challenges and new ideas out there for you to get to. That's really, really sound advice. Thank you. So Martin, what are your thoughts on the question?
Just to pick up on Andrew's earlier talk, this is a fantastic time to join the industry. There's some really exciting new technologies and new markets opening up in aerospace and space. And as you think about where you want to, what really excites you, take all opportunities to build your networks and develop great communication skills by doing things like the UAS challenge, and take all opportunities to join the excellent IMechE and Royal Aerosoc events, and particularly to build your networks and build your communication skills.
Yeah, thank you, Martin. Sound advice there. I think again, just to remind those that as we go through this, really interested to get any follow-up questions you've got as we go through the panel, or any comments you have, really, anything. Just pop them in the Q&A box at the side. We can just keep those going and help the debate forwards, really. So very useful. I think we'll move maybe on to the next question now. So now we're going to move to the more technical question around, so what are the advantages of AV helicopters, and maybe widen that, given your comment, Andrew, around sort of flight taxis. So maybe you want to just reflect on both. I know they're different, but reflect on those. And again, particularly, can UAV helicopters, or maybe the particular question around UAV helicopters again, or sort of UAVs generally, make strategic decisions alongside automatic flight? Again, Malcolm, I'll come to you first on that particular question.
Right. Well, obviously, the elephant in the room on this one is electrification. So the whole move from first of all, there's a limited number of UAV helicopters as such out there. There's I'm thinking maybe one or two that are at any kind of production rate, and they do all have fairly limited automatic flight capabilities. Strategic decisions are pretty much out of the question for the aircraft itself. But yeah, I think at this point the electrification, trying to get the range up, the capacity of the batteries up. That's largely that's the only thing I can really think of at this point.
Okay, thank you, Malcolm. I'll go on just next to maybe to get around to Steve from your perspective.
Sure, I think UAV helicopters is an interesting topic area. I think it really will form part of the urban air mobility push, which is a fairly strong push, and as I think Martin kind of alluded to earlier, it's a very exciting area of development in the industry. There's a lot going on. Company, I think Volocopter in Germany is one of the companies which is quite well advanced in this. I think they have demonstrators flying next year, but those will be piloted, of course. Moving to autonomy or making decisions in flight, that's a very, very large question. But ultimately, I think for the urban air mobility market, we need to get to a point where some degree of autonomy of aircraft, is whether they're rotary wing or fixed wing, is actually certified and safe, because the concept of everyone commuting in their urban air taxi, that's a bit of a challenge if all of the vehicles have to be flown by qualified pilots. So moving towards autonomy, which means that you need control and communication and surveillance and information sharing. There's a huge range of activities for that to become a viable option. It's one of those things that, in my view, the military will probably get there well ahead of civil, because in the military environment, there's opportunities to do things that are far more difficult to do. You can imagine flying a civil helicopter over an urban area. That's very different to flying a military vehicle in a military designated training area, for example. So I think the military will get there first. I think it's a big topic area with a lot of development to come in the very near term.
Thanks. I see exactly where you agree. I think there are challenges there. Again, I'd make an observation around the regulatory environment. So clearly, in order to clear safe flight, safe software, etc., you need to have a regulation to hang that against. I think I observe from when I've looked into that it can be a challenge, because regulations, obviously, this area are developing. So I think until we get the regulatory framework, maybe that's probably one of the areas we will deal with. But yeah, thank you very much. So Martin, from your thoughts?
Yes, I mean, helicopters have a really challenging flight environment, because their utility means that they are taking off from confined spaces, going point to point, often doing some quite higher risk roles. And so the autonomous, making those sort of roles autonomous is really challenging. There are some really interesting, a lot of companies are pursuing a roadmap which is steadily reducing the pilot workload by increasing all of the automation and making the flying of the helicopter less of an issue than the mission management of the helicopter. And that's going to be a roadmap to optionally manned helicopters and then unmanned. Some in the military space, you've got some really exciting programs looking at collaborative vertical flight UAVs, spotting and doing tracking in collaboration with other vehicles, and swarming. And there's some really interesting YouTube videos you can look at, for example, from DARPA, about what they're doing with swarming unmanned aircraft. So they are the technology is here in the sort of test and demonstration phase. As Paul rightly says, regulating that for commercial use in all classes of airspace is quite a way away. And I think we may come on to it in the next question, but there are some big challenges around getting public confidence and trust in autonomous systems.
Yeah, thank you, Martin. Yeah, as I said, that's a pretty good point. And in fact, John certainly was in a question there about the Karman K-Max again. I know that they've not so long ago been working a number of years on a unmanned version of that particular helicopter. And again, it goes back to the role. There's lots of, I think, that I'll make an observation that there is a lot of demand out there for UAVs, and it doesn't take, or UAS, it doesn't take much to look at it and realise that there are many opportunities that could, from a cost or perspective, or certainly for just the relatively low technology flight type of flights we do, hauling freight around, again, absolutely ideal. But again, not yet seeing that grow. But again, that's maybe something we can look at. So again, so Stephen, again, from your perspective, any thoughts on those particular issues?
Yeah, so I'd echo the guys that there about the fact that yes, a lot of the advances will probably come through the military route before we'll ever see it on in the civil market. And also, well, I know the question was based on the advances in the UAV helicopters, but it really is advances across all different aircraft types with UAVs. It just depends on what aircraft suits your mission best, whether it is a helicopter or a fixed wing, and then obviously with the urban air mobility stuff, that the lines between helicopters and VTOL aircraft are getting a bit blurred, and fixed wing as well. We see some added stub wings on some aircraft that's been shared online. And then on the strategic decisions bit of it, yes, there's ethical concerns with military kind of applications. So there's obviously a want to keep human in the loop in that. But then if you go on to some other kind of considerations like collision avoidance, there's definitely been a lot of research on that, and especially with sensors reducing in size, being able to add more radar and lidar capability to the aircraft to sense their environment, and also avoid obstacles, especially when we get into urban air mobility, when you want to try and avoid buildings or anything dropping off buildings. And that's a very important aspect to try and research and get right.
Yeah, thank you, Stephen. Yeah, I think you're absolutely right there. Again, technology moving forward for the sense and void type capabilities. So yeah, but I think we'll see that definitely move forward. In fact, what I'll do is, so I think Yash has asked quite an interesting question on the panel, which I'll probably come actually to Andrew in a second to initially to answer, and then I'll to the panel, which again a slight change on the earlier questions. I think it's quite interesting maybe to bring that in now. He's asked the question, considering the high amount of capital required for engineering startup companies, what advice would you give students aspiring to form independent firms or companies in the aerospace industry? Back earlier on to those with a more entrepreneurial spirit, including Yash has got an entrepreneurial spirit in there. It'd be good to have that. So again, Andrew, any thoughts on that particular side of it?
It's aerospace has been traditionally very hard to get into because there's a lot of background information, but there is, with the electric flight, we're seeing a lot of startups actually get going, and we think it's very much a game changer that has enabled a lot of startups to actually get moving and get into the business because they haven't needed the weight of all the history behind them, all the complexity of, jet engines have become extremely complex. A lot of prior art is needed to progress. The electric flight has enabled people to start up these companies with a lot easier position. So I think we're realistically seeing opportunities for entrepreneurs to get started in the industry that we haven't seen for many years. So and there's certainly a lot of innovation coming out of it. So bring them on.
I think you're absolutely right. And maybe in the panel now, in terms of the Porter cycles, the barrier to entry was obviously a challenge in the old days, much like IT was in the very early days. It was very difficult to get in. Now, as we see, it's much cheaper and easier to get in. And I do feel that UAVs are that moment where you can develop them relatively cheaply compared to obviously Boeings and the Airbuses and Bombardiers who've got big aircraft to deal with. So again, I'll open it up to the panel really, and we'll see how this works in terms of who can get their mic off first. Any thoughts on that particular question around startups and that more entrepreneurial side of the business?
Yeah, I don't. This is Malcolm. I don't think there's any question that the advancement in UAVs has made it possible for the UAM market to actually start. The unmanned or the manned aircraft are prohibitively expensive and very difficult to break into. And if you look at the startups in the UAM market, I think every one of them started with a small unmanned demonstrator, which is not something that you would have been able to do 15 years ago. The control systems available just wouldn't have been sophisticated enough.
Michael, yeah, go on. So, someone else want to come in on that to follow up on what you said?
Just an observation that there's a lot of areas of aerospace specialism where you don't need massive capital equipment. And thinking of sort of digital autonomous systems, AI, machine learning, and so forth, machine vision. There's a lot of independents doing some really world-leading work in that area.
Yeah,
thank you.
I definitely think as well with the amount of startups that are around the world now, and it gives a great opportunity for someone young and ambitious and entrepreneurial to get involved in that. And because they are small teams, you are a key person in that team driving forward, and you are taking a significant amount of responsibility from the start, which is pretty good for your career, so long as you're up to that challenge and welcome it. But you won't be getting the guidance that you probably would get from a more established company. But there's definitely more opportunities there to strike out on your own.
So that's interesting, Stephen. So what you're saying there, I guess, is that you see starting up maybe out the first thing you did. Would you be concerned about that as a straight out of university? Good idea, but again, you've not learned much of that at university. So what's your thoughts on that, moving straight into it?
Yeah, as I said, like it's putting a huge bet on yourself. It's a very exciting thing to do, and but you don't have the backup unless you get some kind of industrial mentor to help you as well. And you see some things like Lilium was quite a student startup with a couple of students from Munich, very young team, very inexperienced, but they did the right thing by looking to experience the industry and getting experienced industry mentors in to help them develop their product. So that's a great way of kind of helping their development and helping the development of the company at the same time.
Yeah, absolutely. And so that was important. The sort of need for capital and getting backing. I guess you said you might need somebody that prove to the organisation what's going to be money. You can do this. I guess you've got a lot of money behind you, but let's assume that we're not doing that. So again, Steve Parker. So that's an interesting point. Again, from your view about abilities for if you've got limited capital, do you think it's important that you've got someone on board who's maybe been in the industry a little bit longer than straight out of university?
Yeah, I think one of the characteristics of the many of the startups, probably most of the startups, is that they do seem very sensible. I think as Stephen has said, that they've in many cases they've employed senior staff, ex-aerospace staff, to help give them a leg up on the route to understanding the business and understanding the regulatory environment and so on. I think from that standpoint, it is a very exciting and it's a potentially high opportunity area. I think there are big opportunities. The one thing I would say is that you need to think about your own kind of risk-reward view of the world, in the sense that there's currently between 250 and 300 eVTOL startups around the world. You can guarantee that in 10 years there won't be 250 or 300 still existing. So it's a very high reward, but equally it's a high risk environment to get into. So I think you need to go into it with your eyes open and be prepared to accept that you might have backed the wrong horse and be looking for another opening in a few years' time. But if you do pick the right horse, getting in early, it's a hugely exciting place to be and potentially a hugely rewarding place to be as well.
Yeah, thanks, Steve. Yeah, exactly. I think as we said, invariably when things move forward, there's a lot of casualties on the way of that. And you said only a small number of them make it, but those are the strong ones. I think it's the idea, as you said. If it doesn't work first time, pick yourself up and go back and keep giving it a go. If you've got a good idea, I think likely it'll come through and maybe you'll find your moment. So you're right. But again, I guess that comes back to you as a person. Can be quite challenging as an individual, I guess, to be able to do that every week. That the confidence and ability yourself to keep going and believe in yourself. But again, absolutely fantastic to do that. I'd agree. It must be very exciting to be part of a startup that's growing. Having got the tiger by the tail, as they say it sometimes, it's really exciting. So that was a really good, interesting. I think maybe we'll move on to the next question. I haven't got a huge amount of time, but we'll certainly get into the next one, and we'll see what we can fit in the next question. Big question, but so we're in the again, panel C has been the biggest design consideration changes in current thinking when it comes to future commercialization of UAS. So again, particularly focused around US, maybe. Andrew already outlined a few thoughts that he'd got when he came in. But again, maybe I'll just start again, open this to the panel. Does anybody have any initial thoughts on maybe what they think has been the major design issues?
Oh, shall I kick off? Commercialization very much means that UAS need to integrate into the air environment alongside manned aircraft, and to do useful stuff, the operators have got to have routine file and fly for doing what we call beyond visual line of sight operations. And the regulations don't currently permit that in all classes of airspace without approval of each flight at the moment. So it's not really commercially viable, but a lot of work is going on. And I think some of the design and technical considerations are particularly around reliable detect and avoid. The aircraft has got to sense weather, other traffic, terrain, all these things. It's got to provide the operator with real trust in its decision making, so that in an emergency situation, or if the system is degraded somehow, the operator's got to be confident that it can understand what the UAV is going to do. And trustworthiness is something that a lot of research is going on into, but there's and then certification of an autonomous system is a big challenge as well, and that's because autonomous decision-making systems are non-deterministic, and so how do you certify something that you don't know with a complex set of inputs what the outputs are necessarily going to be? I'll throw it open to others for other points.
Yeah, I think as well, one thing that really needs to be looked in as well before we see any kind of urban air taxis is cybersecurity. So how do we control these aircraft? Are they remotely piloted? Can there be remote access to the flight path? Are they pre-programmed? And then also what happens when things go wrong? Really needs to be considered as well as part of the development in UAS becoming commercialized.
Yeah, I agree entirely with what Martin and Stephen have said. I think the sense and avoid and the communication, navigation and surveillance aspects from a technical standpoint are probably amongst the more immediate challenges. As Martin said, as soon as you start building an autonomy alongside automation, then you're into a whole new world of challenges. And alongside the technical challenges, I think as Paul mentioned earlier, the regulation, the public acceptance and the safety are absolutely critical. Right now, it's very, very difficult to fly an unmanned aerial system, BVLOS. That needs to change, and for that to change, then you need to get public acceptance. I'm not sure right now that the public would be prepared to see lots of UASs flying over inhabited areas. So there's, alongside the technical stuff, there's a whole heap of non-technical issues that need to be resolved.
Thanks, Stephen. Because I think all the panels so far have talked predominantly about maybe areas that we normally talk about, aerospace design and airworthiness, aerospace design issues. Clearly, there's a lot there about the regulations and the sensors, and that's interesting, Stephen, cybersecurity. So it's interesting that as you said, there's other aspects wider than the traditional, maybe 30 years ago, which would have looked to the aerospace side of the design. Again, finally, so Malcolm, again, from your perspective, any thoughts on this one?
Yeah, I think that in order to commercialize these things, you're obviously going to have to make them applicable to the urban environment, and they're going to be competing with urban air mobility manned aircraft for airspace and so forth. So the first thing that's going to be important is the redefinition of the airspace within the urban environment. And then another thing that I think we haven't considered as much as we should in this on these aircraft is noise. I think people are very, very sensitive to noise, and to have these flying around all day, every day, everywhere, they're going to have to be almost undetectable. So a significant amount of work has to be done on noise.
Yeah, thank you. And in fact, oh, apologies.
Yes, sorry, I was just going to add, I feel that there's one of the benefits we have as the Institute of Mechanical Engineers is that we have interactions with the automotive industry. And one of the key areas I see in the automotive industry is actually moving forward that autonomy and putting autonomy where in places where there are still person-driven cars, and there will be very little opportunity for drivers to actually interrupt a car and actually take over from it. So I think a lot of the autonomous activity will come through the automotive section, and the public acceptance of it will also come through that route.
Thank you. Yeah, yes, absolutely. And I think those linking between sectors, I think there is blurring. I think you're absolutely right. Certainly in the automotive, the autonomous and sort of field, I think you're absolutely right that the challenges that the cars, self-driving cars that we see, will have, challenges in the UAV field. Granted, they haven't got maybe the 3D issue that the aerospace has, but they've got more densely packed roads and things jumping out in front of them, which hopefully doesn't happen quite so often between low level and G-class airspace. But that's a different issue entirely. It's really interesting. So, we are running out of time now. So time's really moved on. Really interesting discussions we've had here. And maybe I'll just, before we wrap up, just reflect a little bit on that sort of question 7. As you see, we didn't get anywhere near it. I'm not surprised. Really good discussions there. But again, maybe just a couple of minutes on that thought around, let's go how to get more people into engineering. Alexander raised an interesting point right at the beginning around kids are fascinated by dinosaurs and space, he says, and I think absolutely right. The space industry is growing. I was absolutely glued to the screen to watch the SpaceX rocket go up with the first manned flight from the US for a decade or so. Absolutely fascinated by that. And my wife, who's a science teacher, has had it absolutely, and they all watched together. Absolutely fantastic. So again, I just maybe a couple of minutes. Any thoughts on that? And again, because we could have a whole day on that conversation, but any thoughts on again how we get more people interested in engineering?
I think that the mention of women there is important because I don't think there's any problem in making engineering attractive to the males. I think that generally males fall into this naturally and are encouraged to do it from a very young age. I certainly know I was. But at the same time, girls at a very young age seem to be discouraged from it still. So there's still a lot of work to be done there. I know I was talking to a woman in our HR department about 6 months ago, and she said that she went to a job fair and she got approached by a number of young girls, teenage girls, but they were all interested in finding out how to get into HR, not how to get into engineering. So it's something that you have to start not just in high school or in junior high school, but during primary school, you need to start telling these people that it's okay to be interested in engineering, even if you're a girl.
A really good point, absolutely right. I mean, there's absolutely no reason, why Eddie wouldn't, and it's pretty sad in this day and age if that's still the case, that certain jobs are seen to be for certain, and anything that makes no reason at all, is there? So again, I guess that's right back at the core of societal of getting in there, really. And we have a quick thought on this.
I think I agree particularly with Malcolm's point about starting young. I think once children get into secondary school, if they're not interested in engineering by that point, then it's almost certainly too late. You need to start, as Malcolm said, really young, primary school and up. And engineers, we can make a big difference by supporting STEM activities, which I think are now largely going on globally. Obviously, women in engineering, the lack of women rather than engineering is a particular problem. But let's extend that to other minorities. I think my observations around the industry is still very pale and male. I think addressing both of those is important. In many cases, women is a more acute problem, but there's also, I think, a lack of diversity in general in the industry. I think we need to be addressing that as a priority problem, because getting that diversity into the industry will add to what we can do. It brings different points of view, different knowledge and different aspects to everything that we do.
Absolutely right, Stephen. Why shouldn't all workplaces reflect, the background from where they came? We should be absolutely right. It should be a reflection of entirely of a population, not a particular element of it. And again, engineering can be that, and getting in early is really important. I understand that people often say that role models are really important in that and moving forward. So Stephen, what's your thoughts about the importance of role models for engineers moving forward and people going into the career?
Yeah, I think it's very important. Like our company would do quite a lot of community outreach into primary schools, and we do send a range of diverse people from our company to show that it is accessible to get into the aerospace if you want to do it. And it is good to have things like the IMechE challenge and more things up on the internet, like Tim Peake and stuff like that kind of show role models and show people that are within the industry and have went through the process of going from school through college and into the industry and what they're doing. I also think that we should try and help people get access to education. So at the minute, in the UK, there's mostly a £9,000 fee a year for engineering. Whenever I did my degree, I had to pay about £100 a year because I did my degree in Ireland. You see in different countries as well where there are key shortage of skills, that they leverage the cost of college and lower it down for the key skills that are required for that economy, whether it's engineering or nursing or doctors, and hire up the ones that maybe are in oversupply to balance the books and allow universities to still provide the course content that they want. And I think that's definitely something that the UK government could really look into to encourage engineering and remove that financial barrier of getting into engineering from a lot of people as well. Because if they want to get into aerospace, they can. And then also we need to remind people as well that you don't just have to do a degree to get into engineering. There are other routes like apprenticeships. As you were saying, Paul, like if through the RAF and within companies as well, there's other routes of getting into aerospace. If you really want to do it, you can do it. You just need to go out and do your best and make the effort to try and get in.
Thanks, Stephen. I think that's really important. Yeah, the number of ways in. I suspect if we sat here now and had a time to talk about how we all got in, we all have found a different route in to the careers we've got into. So absolutely right. There's no one size fits all. But I think that's really important. And again, we should offer those again for absolutely depending on your background or how you want to get into. Some people, more hands-on, and some people don't want more design work or whatever it is. So absolutely right. Really interesting. But thank you for that, guys. Conscious of time, so we kind of had it now in terms of time for this before we move on. So conscious of keep people going. So first of all, clearly, I need to say thank you very much to Malcolm Foster, to Steve Parker, Stephen Phillips, Andrew Bradley, and Martin Soltau for joining the panel. Really interesting discussion there. We covered everything from careers to how do you move out of university into engineering to some design issues, and certainly where we think UAVs are going in the future. A lot of really good food for thought there that I'm sure we would carry on for a number of hours if we had the chance. Thank you for your support. We're learning how to work in this new world order that we are. I think that worked pretty good. So without further ado, thank you for that. just to remind you all that we've got the UAS Challenge actually having the virtual award ceremony on Friday at 2:30. So again, hopefully you've got your invite for that. If please speak to Christina or Elena about getting your onto that, because again we've got quite exciting award ceremony to be done. That and some interesting videos and feedback from the team. So hopefully I will see you or hear you virtually on Friday. Everybody, thank you very much for joining. Those that joined, really useful questions at the side. Again, we recorded these, some interesting food for thought on some of the comments made at the side, which we'll take away and look at. So thank you very much indeed, and see you on Friday. Thank you. Goodbye.
Thank you.
Thanks, everybody. Goodbye.
Thanks. Bye now.